Hello everyone, welcome to Pepcoding. So in this video, we are going to start the next question of our tree series. And this time the question that we have is vertical order traversal of a binary tree second. Okay. So it is the second question of this vertical order traversal. So if you have not watched the video of first vertical order traversal of a binary tree, then for that I request you to kindly watch that video, because in that we have discussed in a more precise way that what is this vertical order traversal and how we can do that. Okay, so let us move on to this question and let us see that what is what is the different in this question. Okay, and then we'll try to solve it. Okay, so let us go to the board. And okay, so a binary tree is given to us. We all know that what is vertical traversal. Okay, because in previous video we have already completed the vertical traversal first. So now we'll be solving this second question. I'll tell you that what is the difference in it. So in this, see, it is one vertical line, right? It is second one, it is third one, and these two are on the same horizontal level. And this is fourth, this is fifth, this is sixth level. Okay, so these are some vertical levels. And what we have to do in previous, like in previous video, we or in the previous question, we have printed it such that at zeroth we have 6 comma 10, right? At first we have 7 comma 19 comma 4 14, right? And at 2 we have 5 comma 1 comma 9 comma 21 comma 19, right? And at 3 we have 4 comma 11 comma 6, and at 4 we have 2, and at 5 we have 7. Okay, so this is what we have. So what we have to do, this is what we printed in previous video. Okay, so let us not talk about this, let us talk about the changes that we have in this question. So in this question, what we have to do, like in previous question, the order doesn't matter for this, right? This 1 and 9 order does not matter for this, but in this order matters. Okay, so how is it how the order matters? See, for this, for in this question, what we have to do, if there are some nodes in the same vertical or the same horizontal, in the same horizontal level, if there are some nodes in the same horizontal level, then for them you have to print them in the ascending order in such a way. Suppose it is 1 9, right? 1 9 is already in the ascending order, on the sorted order, right? 1 will come first and 9 will come in after that, so it is sorted order. Okay, so where is it? Here is it. So it is sorted. But for suppose this 19 and 14, so 19 and 14 coming like 19, and then after that 14 is coming, right? But these two are on the same horizontal level, so this order is wrong. So what we have to print, we have to print 7, then 14, and then 19. Okay, the one which is smaller will come first, the one which is smaller will come first if they are on the same horizontal level. Okay, so this is what we have to achieve. Okay, so I hope that the question statement is clear. What we have to do, so suppose in this where is 11 6? 11 6 is in third, right? 0 1 2 3, yeah, 0 1 2 3. So it is here. So what we have to do in this, suppose 11 6. Okay, 11 6, so we don't have to print it like 11 comma 6, we have to print it in ascending order. 6 will come first and then 11 will come. Okay, so this is what we have to achieve. So in third level it should look like, in third, I hope that I'm blocking your view. So it would be like, in third level it would look like not 4 11 6. 4 11 6 is wrong, but it should be printed as 4 comma 6 comma 11. Okay, it is the right order. So this is what we have to achieve. So think that how we can do this. Okay, think you can think that how we can do this. So till then, let me erase it. Okay, so okay, so what you have to do, let me tell you what you have to do. You have to maintain the order this time, right? That means the one which is smaller, the one which is smallest, we can say the one which is smallest in the horizontal level, the one which is smallest in the horizontal level will come first. Smallest in horizontal level will come first. Horizontal level will come first. So this is what you have to do. So if you can think properly, then you have to give a priority to a smaller element, right? You have to give the priority to a smaller element. So which data structure you can use for this? Can you think about any data structure which can give a priority to your sum, to your element on the basis of its value? Okay, on the basis of its value means if it is greater or smaller, which data structure gives this priority? So if I'm not wrong, we can do this with the help of a priority queue, with the help of a priority queue. Because see, for doing the vertical traversal we have to do the BFS, right? For doing BFS we need a queue, but in this time we have to we also have to arrange the priority. We also have to maintain, we can say, not arrange, we have to maintain order of horizontal order. We have to maintain order of horizontal priority, right? We have to give priority in the horizontal order. Okay, so this is what we have to achieve. So how we can do this? We can do this with the help of a priority queue, and with the help of a priority queue we can also do BFS, right? We can also do the BFS that we have already seen in graphs level 1, that we can achieve BFS like Dijkstra and Prims. We have used priority queue in them, right? So now we are clear that we are going to use the priority queue, but how we are going to use, and how many priority queues are needed? See, what will happen, suppose if you are thinking of using only one priority queue. Okay, suppose you're thinking, okay, you reach to a conclusion that you are going to use a priority queue, but now you have to think the number of priority queue yet that you are going to use. Okay, because you do work for each level, right? You do work for each level. So suppose you are doing some work in one priority queue only. So suppose for this suppose it is 0, it is 1, it is 2, right? It is 2. So we used to send a pair, right? We used to send a pair. So suppose we have 7 with horizontal level 1, okay, and we have at the same time 4 with horizontal level 3, okay, and at the same time we have added uh, suppose this is not there, okay, because at this time this cannot be there. So we'll add some elements like 4 with horizontal level 4 with horizontal level uh, 3, and 6 with horizontal level. We have 6 with horizontal level 0. We have 1 with horizontal level 2. Okay, so in this, if we will take out it on the basis of this value, so before this element will be processed, my this one will come out of the priority queue, right? This one will come out of the priority queue. Why? Because one has, we are giving priority on the basis of node value, right? We are giving priority on the basis of node value. This is what you know, and this is what I also know. Okay, so if I'm going to use only one priority queue, then what is the possible error that we can face? Okay, or what is the possible problem that we can face? So as you can see in this, see, we have these elements. See, suppose first of all I pushed it, okay, I pushed 5, then after this I removed it and pushed 7 and 4, okay, and then after that I removed 7 and then I pushed 6 and 1, okay, but after this one should be processed, right? One is at this level, it at this horizontal level. So 4 should come out, but instead of 4 my 1 will come out of the priority queue, because 1 has more priority. And similarly after 1 will come out, we'll have 14, we'll have 11. So suppose in place of 14 or 11, if we'll have 1 here or 2 here, right? So these will come first. So before that these will come first, okay, if there is some number which is smaller than 4, okay, so 4 will never come out, 4 will come in the end, okay, 4 will come out in the end, which will which will we can say this will change our vertical order, right? This will change our vertical order. It is no longer a vertical BFS, right? The for which we use the BFS, it will not give us the same order. So it is not the right thing that it is not the right trick of using only one priority queue, okay. So what we will do, okay, we can also do it with the one priority, but for that you have to maintain two levels. Okay, I'll tell this in some other video, but for this time I already told you that if we are going to use similar trick, or we are going to use the similar algo that we used in the previous, that means in the question vertical order traversal or binary one. Okay, in that question, if you will use the same logic, then in this way, if we are using only one priority queue, then this will give us the wrong answer. Okay, it will not give us the right order. So what we can do, let us see. Okay, we are going to use two priority queues. Okay, what I'm saying, we are going to use two priority queue. So what will happen with it, let us see. Okay, so there is one priority queue. Okay, and another one will be, okay, it is the second priority queue. Okay, so let us say this one. So this is my these are my two priority queues, and what I'll do, I'll send a pair. I'll say this one is my parent priority queue and this one is my child priority queue. And in one level, I'll give this my nodes. I mean, I'll insert my pair in it. Okay, and after that, it will prepare child queue, I mean child priority queue for the next level. Okay, for one level my parent queue will work, and it will prepare my child queue for the next level. And when my level will end, I'll send all the elements which are in my child queue into my parent priority queue. Okay, I'll send these many elements into my parent priority queue. Again, my this will be emptied, right? This will be empty after the level, after when I will send all the element to this priority queue again, right? That means after the end of a level, when this will be ended, and this will fill with some of the element in a level. Suppose this will fill with these many elements. Okay, this 6192. Okay, this child queue will be filled with these 6192. So what will happen is, my this priority queue this priority queue will ask me to give me the elements of another level so that I can process them. Okay, so that I can process them. So I will send these elements in it. Okay, and my this priority queue will again be empty, and then again my priority queue of this parent priority queue will prepare my child priority queue for the next level, that is for this level. Okay, for this level it will again be prepared. So this is how I'm going to do this, and there will be no problem occur, like we discussed, that if we'll use only one priority queue, then this will be, if this will come out, then this will insert these two, right? And this should come out first, but this will come, right? So it will not, we will not face these kind of problem if we'll use two priority queue. So let us use two priority queue and do it. So how we can do this, let us see. So first of all we know that we are going to calculate the width, right? So we'll not talk about how to calculate width and all, so we'll simply calculate the width. So width will be like this. Okay, I'm making the shadow somehow. Suppose these are shadows. So my width function which I'll write will give me width. This will be 0 1, I mean 0 minus 1 minus 2, and this will be 0 1 2 3, right? So my width is 3 minus 2 plus 1, that is 6. Again my width is 6. Okay, so my width is 6. That means what I will do, okay, we will write it somewhere. First of all, width is 6. Okay, and then after that we'll give it the indexes, that is, it will be 0, it will be 1, it will be 2, it will be 3, it will be 4, it will be 5. Okay, so for that, if you have not watched the video approach 2, this method I discussed in approach 2. Okay, there are two approaches for first question. That means there are two approaches for vertical order traversal binary tree 1. Okay, there are two approaches for that. First approach is using hash map, second approach is using this width method. Okay, so you should watch both the videos, that means hash map also and also the approach 2. Okay, so that you could be clear about both the methods. Okay, So we are going to use the queue, right? And priority queue, I mean priority queue. When I'm saying queue in this, it will say priority queue. Okay, so let us do what? Let us insert the pair. Okay, let us begin with inserting the pair. So first pair will be inserted 5, right? 5 will be inserted with 2 horizontal level. Okay, so 5 will be inserted with 2 horizontal level, and then after that, okay, I'll now write this. Okay, and then after that we will remove it, and it will prepare my child queue for the next level. So it will insert 7 with 1 and 4 with level 3 in it. Okay, so these two will come like this. Okay, and in my second level I'll see that I have 5. Okay, in my second I'll see I have 5. So I'll write it somewhere like this: 0, 1, 2, 3, 4, and okay, let's write it again. So it will be suppose 0, 1, 2, 3, 4, 5, 6, right? Not 6, till 5 only. Okay, so this will be my order. I'll print it here. Okay, so mark arrow also. These are my array list. Okay, or we can say vector, anything. Okay, so my second my child priority queue is prepared for the second level, right? So what I'll do after coming to this level, simply I will blank, this will be blank, right? Because here we removed it, and then only, okay, which one was removed? 5 was removed, right? So add 2, we'll write 5. We found 5. So now it is removed, and these two will go to this. So let us try to take these two out. Okay, okay, so these two now are here now. Okay, so now what it will do, simply it will now take 7 out. So 7 will come out and will prepare child queue for the next level. So it will insert 6 with level 0. Okay, and it will insert my 1 with level 2. Okay, so this will do, this 7 will prepare ch like this. Okay, I mean child priority queue like this. Okay, and now we will, as as this is removed, so we will also write 7 at 1. So we found 7 at 1. Now my 4 will also be removed. Okay, 4 will also be removed, and what we'll do, at 3 we'll write 4. 3, we found 4. Okay, and add its add their children's, and children's are 9 with level, it is 3 minus 1, that is 2. Okay, and here it is 2 at level 4, right? 2 at level 4, 3 plus 1, 4. Okay, so now it is empty, right? It is empty. So let us remove these. Let us remove these now, and they will be passed to my parent. So now it is empty. Okay, so I hope all the elements that we met so far are in this. 5 is in, 7 is in, 4 is in, right? And then yeah, these 4 are here. So what we will do now, 6 will be removed. At 0 we found 6. At 0 we found 6. So now 6 will prepare for the next level, that is it will insert 19 with 1, right, we have 1, and then we will go to this. Okay, 6 is inserted, right? And then we found 1 for 2. At 2 we found 1. Okay, so this is what we will write, and then after that what we will do, okay, we are doing wrong, really sorry, but we are doing wrong. We are doing completely wrong. Let us start it up again. So first of all, my 5 is removed. Okay, it is okay. We have not seen that it is a priority queue. We did it as it is a queue. We have to solve it as the priority queue, right? So let us solve it again. Let us do it again. So what we'll do, simply this. Okay, so first of all I'll mark arrow, 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 arrow. Okay, so 5 is removed, right? 5 is removed, no problem in 5. So let us write 2. Here we have 5. Okay, so these will now go to our, these two will go to our child. So that means we'll remove it and these two will be shifted. These two will be shifted, and due to this, which one will come out? Now it is a priority queue, so 4 should come out. Okay, 4 should come out. So at 3 we found 4, so this is what we have to do. Okay, okay, so 4 will prepare for the next level, that is 9 will come with the level. 9 will come with level. It is at 3, so that means left means 2, so 2 will come with level 4. Okay, so this is what it will do. So now 7 will come. 7 will come, so 7 is at 1, so we found this. And now what we will do, we will prepare this 6. Okay, we will prepare the 6 at level 0 and 1 at level 2, right? 1 plus 1 2, so 1 at level 2. So this is how it will go, and then it is empty, so we will fill this. We'll fill this. So let us remove this and we'll fill this. Okay, so we'll shift them in my parent queue, right? So what will happen now? See which will come out first, 9, 2, 6 or 1? Obviously 1. Okay, 1 will come out, and we will see 1 at 2, right? At 2 we'll see 1. Okay, at 2 we found 1, and then after that we have, it will prepare for the next level, that is 14 for level 1, and okay, it is 14 for level 1. Okay, 14 for level 1 and 11 for level 3. So this is what it will do. And then after that we have 2 here, so 2 will be removed. At 4 we found 2, simply. Okay, at 4 we found 2, so where is 2? 2 2 2, here it is 2. Okay, at 4 we found 2, so 2 will prepare next level, so that means it will prepare 6 for level, it is at 4, that means for 3, and 7 for level 5. Okay, so this is what it will do, and then 6 will come out. At 0 we found 6. Okay, no issues. So at 0 we found 6, so 6 will prepare for the next level. Where is 6? Where is 6? This 6, right? So it will prepare 19, so 19 with level 1. Okay, now 9 will come out. 9 will come out, that means where is 9? Where is 9 at level 2? At level 2 9, this, right? So now at 2 push 9. Okay, and what else we are going to do? Okay, prepare for the next, but there is no child. It has no child, so remove them and fill your parent queue again. Okay, let us make a parent queue. Okay, okay, so this is our parent queue, so let us fill it again. So again our parent queue is filled, but our child queue is also okay. Now, so make it a little big. Okay, so this will be clear now. And okay, so 14 is at level, I'll write it again. 14 is at a level 14 is at level 1 was at 2, right? So 14 is in 1. Okay, so 14 is in first level. So which one will come out? 6 7 19, 6 will come out. I'll say 6. At 3 we found 6. At 3 we found 6, right? At 3 we found 6. So what will happen now? Now 6 will add its next, so that means at 3, that means at this, so 6 will add 16 with level 3 minus 1, that means 2. Okay, okay, and then after that which will come out? We also return 6, right? Okay, and then 11 14 7, 7 will come out. So 7, what will do? 7 7 at 5 we found 7. Okay, no issues. And what will do? It will prepare for the next level. Where is 7? So it does not have anything. Okay, so now which one will come out? 11 will come out. So 11 at 3 we found 11. Okay, no issues. And after that 11 will prepare for its next level. There is no one in the next level on the 11. So will what we'll do? We'll move for the next element, that is 14. Okay, now 14 will come out and will, at 1 we found 14, so we'll prepare for the next level. So for the next level, where is 14? 14 will add 14 at 1, right? It is 14 at 1. So 14 will add 10 at 0, and 14 will add 21 at 2, right? 14 was itself at 1, so it will add 21 at 2. And now 19 will come out. At 1 we found 19, and 19 will, where is 19? 19, here is it. So 19 does not have anything, okay, as their child, and 19 does not have anything, so 19 will not add anything. And now we'll move on to our child queue. Okay, our child queue will now fill again our priority queue as this level is completed. Okay, so I hope you are getting my point, that what I'm doing, it is similar to that of queue. It is similar to that of queue. That is why initially we started like it is queue only. Okay, because we already have to apply same kind of logic, so I just had did that mistake only. But now we are going right. Okay, now we are going right. We'll also match our answer so that we can check if it is correct or not. And then what we'll do here in this, which will come out? 10 will come out. Okay, 10 will come out. So at 0 we found 10, at 0 we found 10, and we will prepare for the next level. At 10, where is 10? Where is 10? Okay, there is nothing in the next level of 10. And then after that we will remove the 16, so the 16 will be at this 2, right? So now it will prepare for the next level. Where is 16? 16 does not have anything. Now we have 21, so 21 will be removed. 21 also does not have anything, but at 2 we found 21. Okay, so this is what we'll write. So are we getting in the ascending order? We have to check it, right? Everything, both child queue and priority queue are empty now. Both child queue and priority queue are empty now. So at this level nothing will be filled. Okay, and I already have made a check that when my parent queue is empty, you should stop. Okay, so it will stop here, and then after that we just have to return this thing, this list, this answer we have to return. So let us see, is it the correct order? So at 0 we should get 6 10, correct. And at 1 we should get 7, then 14 19, right? 7, then 14 19, 7 14 19, correct. Okay, no issues. Then at 2 we should get 5 1 9 16 15. At 2 we should get 5 5 1 9 1 9 16 15 16, okay, 16 21, sorry, 16 21, it is also right. And then at 3 we should get 3, I mean 4, and then 6 11, 4 6 11, absolutely correct. And then at 4 we should get 2, absolutely correct. At 5 we shouldn't get 7, okay, it is also correct. So I hope that you are getting my point, that how we are getting this order. Okay, so let us little bit talk about the time complexity of it. Okay, we have seen the order, we have maintained, we know the logic that we are going to use, but now let us talk about the time complexity. Okay, so let us talk about the space complexity. Okay, before time complexity, let us talk about the space complexity. So how much space we are using? So see, we are using 2 priority queues, right? And at every level we have some elements in the first, and some elements are in second. So overall, if we are talking in an average, we are using O of n space. Okay, we are using O of n space in an average in the worst case. So it is the space complexity. And let us talk about the time complexity now. Okay, let us talk about the time complexity now. So what would be the time complexity? So if I'll talk about time complexity, then it would be, see, my addition and removal time from the priority queue takes log of n. N is the number of elements, right? n is the number of elements. And for the first level, what I'm doing for one element, right? For 2 power 0, I'm doing this work. So 2 power 0 log 2 power 0. At second level, I'm doing this work for 2 power 1 elements, and it will take log 2 power 1 time. Okay. And at second level, at third level, I'm doing this for 2 power 2 elements, and log, it will take time, log 2 power 2, right? Similarly, at h height, I'll take 2 power, there will be 2 power h elements for a balanced binary tree. Okay, for a balanced binary tree I'm talking about, and this will become equals to log 2 power h. Okay, so it would look like this. So let us see what would be the time complexity for this. So if I'll solve this equation, okay, if I solve this equation, let us do this here. Okay, let us do this here, and then we will see that what we will get. Okay, so Tn becomes equals to, in the first level, I'll have 2 power 0 into log 2 power 0 plus 2 power 1 into log 2 power 1 plus 2 power 2 log 2 power 2 log 2 power 3 into log 2 power 3 till h minus 1 into 2 power h minus 1 into log 2 power h minus 1 plus 2 power h into log 2 power h. Okay, so it would look like this. So what would be the summation of this? See, log 2 power 0, 2 power 0 means 1, log 1 is 0, so this term will be neglected. Okay, log 1 is 0, 0 into 1 is 0. Okay, so we'll start from here. So 2 power 1 will be here, and log 2 and 1, this is log 2 base 2 will become equals to 1 into 2 power 1 plus log 2 base 2 1 power 2, so this will become equals to, this is 2 power 2, right? So 2 into 2 power 2 plus 2 into 2 power 2. Similarly, this will become 3 into 2 power 2, 3 into 2 power 3, 3 into 2 power 3, here it is 2 power 3, right? So this will, see, I'm using this property that log AB of n will become equals to n log AB. Okay, and here it is BB, right? Log 2 base 2. So log 2 base 2 become equal to 1. So when base and the number and the log are same, then it become equals to 1. Okay, so this is what I'm using. So don't be confused, and let us move on. So there's 3 into 2 power 3 and 4 into 2 power 4, right? 4 into 2 power 4, and then here we'll write 2 h minus 1. Okay, 2h minus 1 into h minus 1, right? H minus 1 into 2h minus 1, and similarly h into 2h. So it would look like this. So now it is Tn. It is Tn. So if you observe this equation, then can you see that it is a APGP? See, 1 2 3 4 5 6, okay, till h, till height h, and it is 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power, it is a combination of AP and GP. So it is called APGP, right? APGP equation. So how we are going to solve this? Let me tell you. Let us see how we are going to solve it. So let us multiply this equation with 2. So what it will give us? It will give me 2Tn is equals to 1 into 2 power 2 plus 2 into 2 power 3 plus 3 into 2 power 4, and it will be h minus 1 into 2 power h and plus h into 2 power h plus 1. Okay, this will become equals to this. So now if you will subtract these two, then what will be the output? So it will, I'll see, here it is t power n, right? Minus t power n, when it will be subtracted, and when they will be subtracted, it will be subtracted with, this will be subtracted with this, then this will give me the result as 1 into 2 power 1 plus this will be subtracted, right? So this will become equals to 2 power 2 will be common, then 2 minus 1 1 into 2 power 2, here 2 power 3 is common, so 3 minus 2 1 into 2 power 3, right? and similarly it will become equals to 1 into 2 power h, right, minus h into 2 power h plus 1. Okay, so this is what it will become. Now after this, what we are going to do after this, we will see that it is a GP, right? It is a GP. You can see 1 into 1 1 into 1 1 into multiplied by something will give me the same number. So it is 2 power 1 2 power 2. So GP till 2 keep 2 power h. So what it will give me as a summation? So as a summation it will give me, see, summation Sn is equals to a Rn minus 1 upon R minus 1. Okay, so this is the summation of GP. So I'll use the same thing, that is 2, that is a is 2, right? 2 r is 2 power n minus 1, that means h minus 1 2 power h minus 1, okay, upon 2 minus 1. Okay, so this is what it is, and here don't forget to write minus h into 2 power h plus 1. Okay, so here it will look like this, and it is minus t of n. Okay, so it will become equals to, the denominator will become equal to 1, and then it will become equals to 2 raised to power h plus 1, okay, minus 2 minus h into 2 raised to power h plus 1. Okay, so 2 raised to power h plus 1 minus h into 2 raised to power h plus 1. So let me first of all make this one positive, so we'll multiply it with negative. So this will become equals to Tn is equals to h into 2 raised to power h plus 1 minus 2 raised to power h plus 1 plus 2. Okay, this will become equals to this. So see, it will become equals to h minus 1 into 2 raised to power h plus 1 plus 2. Okay, so this will become equals to this, and what else we can do? So if we'll solve it, then what is the value of h here? Do you know what is the value of h? I'll say it is log n. How? Let us prove it. See, in a balanced binary tree, if we'll see this, okay, then at every level we have, first level we have 0 element, 2 power 1, then 2 power 2, then 2 power 3 till height h, that means 2 power h, and the number of elements are n. So n is equals to, this is again a GP, right? Again a GP, that means 2 and 2 power n. 2 power n means 2 power h minus 1 upon 2 minus 1. Okay, and it will become equals to 2 into h plus 1 minus 2, right? So okay, a is 1 here, right? 2 power 0 1, 2 power 0 1. So I wrote it bit incorrect, so it is 1. So 1 into r is 2, right? R power n minus 1 into n minus 1, that the r minus 1. Okay, r is 2. Okay, so we'll have 2 power h minus 1 upon 1, right? So now take log both sides. So when you will take log both sides, then you will get log n is equals to 2 power h, I mean log 2 power h. So we can neglect this minus 1, right? So log n is equals to log of 2 base 2 power h. So when these are same, so first of all this will come forward. Okay, this will come in front of this, as the log property says. Okay, so log n is equals to h log 2 and this base 2. Okay, log 2 base 2. So log 2 base 2 will become equals to 1. So now my h is equals to log n. Okay, so this is how I proved my height is equals to log n. Okay, let us move back to that. Where is it? Here we were, right? Yes, so let us remove this thing because we don't need this. Okay, this was just a proof, and if we'll solve it, then this will become equals to log n and 2 raised to power log n plus 1 plus 2. Okay, so now this will become equals to n plus 1 plus 2 and log n. Okay, so basically this will become n log n plus log n plus 2. Okay, something like this. So if I'll take in terms of on, if I'll take in terms of on, then what will be the time complexity? If I'll say find out the largest term, that will be the time complexity, then you will say my time complexity of O of n log n, right? So this is the time complexity for this, right? So I hope it is clear. So we talked about the time complexity, we talked about how we are going to solve it, we are going to use two priority queues. So let us write the code. So let us now look into the code of it. Okay, so let us start the code. And first of all, in code we are using two priority queues, right? So let us make the priority queues. So priority queue and priority queue of type QUEUE, priority queue of type Q pair, right? We are going to insert a pair which will consist a horizontal level and a node. So Q pair, let's say Q pair, and we have to tell it that it is a min priority queue. So vector Q pair, and also we have to pass a comparator so that it can give us the value on the basis of node value, right? It has a pair, so it cannot be able to differentiate between on the basis of what, on the basis of level, or on the basis of horizontal level, or on the basis of node value. I have to return the value. Okay, so we are telling this priority queue that you have to return us the value on the basis of node values. Okay, so this is my first priority queue, and the second priority queue will be my child queue, right? And the child queue will prepare for the next levels. Okay, I'll prepare child queue for the next level. So this is my CQ. Okay, CQ and PQ, there are two priority queues. And what else I need? I need width, right? I need width also. So I'll write here vector of int arr, size will be 2. Okay, and this vector will be filled in my width function, which will give me the width of this tree. Okay, width of this binary tree. So I'll fill the by default value 0. Okay, at the first index I'll have my minimum, at the second index I'll have my maximum. Okay, I mean the maximum width and the minimum width. Okay, so I will not discuss the width code here. We'll simply write the width code because we already have discussed it. It will be void width, and we'll pass it some tree node root. Okay, and horizontal level, and the third thing will be vector of int okay. So these three things will be passed. This is tree node star. Okay, and then what I'll do, if root is null, so simply return from here. First of all, return, and then after that a left call and a right call. But before that you have to calculate your max and min. So arr of 0 is equals to mat dot min of hl comma arr of 0, and ar of 1 will be hl comma arr of 1. Okay, and it will be not min, it will be max. Okay, at first index I'll have my maximum width, at 0th index I'll have my minimum width. Okay, so it would be something like this. We reiterate it. If it is my tree, then this will be 0, right? So it is -1, -2, and it is 1, 2, and 3. Okay, so this will be in my max. That means arr at 1, and this will be at my arr at 0. Okay, so this is what I'm saying. So I hope that it is clear, and let us move on to our code. So after this, our recursion will help us in getting the max from from whole tree. So what I will do, I'll simply do with root dot left Okay, we'll go to left, and after that, when we'll go to left, we'll do HL minus 1. Okay, because when we are going to left, we are doing HL minus 1, pass ARR as it is. And when we are going to right, what we'll do, we'll simply go to right first of all and HL plus 1. Okay, because this time we'll increase the level. So that's it. This will give me the array which will contain my maximum and minimum width. Okay, so here I am, and here is my priority queues. So let us now begin with our actual code. That is from here I'll calculate my width, I'll pass root in it, and initially 0 will be my horizontal level. Okay, also as I'm making a queue pair, so let us make a queue pair. Okay, so public, not public, it is class queue pair, and in this I'll write int HL and tree node star. Okay, one more thing that I did incorrect was this root dot left, root dot right. So and anywhere else? No, I think that's it. And here I have 0, and initially my vector, okay, my vector will be ARR. Okay, so this will give me the vector, this will fill my vector. Okay, and I'll have my range is equals to, I'll write int range is equals to max minus min plus 1, right? So ARR at 1, max minus min, that means ARR at 0 plus 1. This will be my range. Okay, this will be my range. So what I'll do, I'll make a vector of integer. Okay, vector of integer, that this is what I have to return answer, and I'll make it of size range. Okay, I'll make it of size range because this many levels I'll have, this much width I'll have, and at each level of width, but I'll have a vector. Okay, I'll have a vector of integer. So this is my priority queue in which I have pair. Okay, it is not done. So node and queue pair constructor. So I'll write here tree node star node comma int HL. So this dot HL equals to HL, and this node equals to node. Okay, so this is it. And after this what I need to do, okay, here, okay, I have to tell this priority queue that on the basis of what you have to do the sorting, that you have to give the minimum value on the basis of what. So on the basis of this node value. Okay, so I'll write a comparator, that means struct comp. Okay, and after this, okay, one more thing, don't forget to make it public. Okay, so after this what I'll do, I'll simply write my bool operator. So bool operator. Okay, and in this I'll write const queue pair and a comma const queue pair and b. Okay, and after this what I should return a dot node dot val is greater than b dot node dot val. Okay, so let us write it in the correct way. A dot node, okay, val will be like this, b dot node val will be like this. Okay, so now this will return me value on the basis of this node value. Okay, so now my priority queue is done. Okay, I gave the commands for taking out the values from the priority queue, but first of all let us fill the first element in the priority queue, pq dot push. Okay, pq dot push queue pair, and in this queue pair I have to fill a root value, and another is absolute value of what, ARR of 0. Okay, so this is what I'll pass. And okay, I think one bracket is missing, right? 1 2 3, 1 2 3. Okay, so now what I have here, I just have to run the BFS, right? I have to run the BFS. So while pq.size is greater than 0, till then I'll do work, and simply I'll check the fast size first of all, as I'm doing the work for each level. Int size is equals to pq.size. Okay, and after that I do the work while pq.size, I mean size minus minus. Okay, size minus minus is greater than 0, till then I'll do the work. And what work I'll do, I'll first of all get my q pair rem is equals to pq.top. Okay, so first of all remove it, that means pq.pop, remove, then work is okay, work is I have to answer dot get that rem.hl. Okay, at this horizontal level, what I should do, I should add or push back, push back. Okay, push back. What I should push back, I should push back rem dot node dot. Okay, so this is what I'll do, rem dot node dot well, or we can say rem dot node arrow well. Okay, and okay, vector width, this range. Okay, it is done, and priority queue is done, pushing in priority queue is done. Okay, and after this what I should do, okay, I have did my work, and now I have to prepare for the next level. So what I will do, I'll simply check if my rem dot node dot left is not null. Okay, if it is not null, then I should add what, I should add in cq dot push q pair, and in this q pair I should push what, rem dot node left comma rem dot hl minus 1. Okay, and then after that I have to do same for my right. So right plus 1. Okay, and while going to right I'll do plus 1, and anything else c. Okay, cq. Okay, now it is done. Okay, it is prepared for the next level, but when my level will be finished, what I'll do, I'll make my priority queue temp. Okay, priority queue of q pair comma vector of q pair okay, and q priority queue of q pair comma vector of q pair, and let us give it a count. Okay, and now that will be temp, and that will be pointing to pq. Okay, and what I'll do pq is equals to cq, and cq will be equals to temp. Okay, cq will now point to temp. So in this way my elements in my child queue will get shifted to my parent queue. Okay, and then from here I'll simply return answer. Okay, when this will be done, I'll have my answer, so I'll return my answer. And okay, so let us give it a run to check if there is some compilation error. Okay, let us run it. There's some compilation error. Okay, it is at 24 we did mat.min. So mat.min is not a function in this, it is a Java function. So in this we have only min and max. So min and max. Okay, so min h1 AR at 0 and min hl, I mean horizontal level, and ARR at 1. Okay, so this is it. And anything else? Yeah, there is one more compilation. answer dot get. Okay, answer dot get. Where is that? It is at answer dot get, where I have written answer dot get. Answer dot get here. It is not answer dot get. This is not the way to get element and vector. So here answer at rem.hl. In that we are going to push back my node var. Okay, so it is accepted. And now let us give it a final submit for all the test cases. So it is accepted. So I hope that you got this question completely. Okay, and we gave very much time to it. We understand every aspect of this. So this is the way that you do binary, I mean vertical order traversal in a binary tree. Okay, so after this we'll meet in the next video. So till then, goodbye, and share this video with your friends. Also like this video, and also subscribe to our YouTube channel if you are new to this channel, and we'll meet in the next video now. So goodbye.